13.2, we're talking more about factoring and trig review. Okay. We've talked about grouping. We've kind of reviewed a lot of them. The only one we didn't review yet is substitution. So, who remembers how to do substitution? What would I do on example 1? Hannah. You guys are so smart. All right, so let z equals a plus c. So then we rewrite this equation to be z squared plus 5z minus 14. Okay, remember that this outside number is your multiplying number and the middle number is your adding number. If you're ever not sure, just write the list of numbers that work. For 14, when they multiply, you have 1 and 14 and you have 2 and 7. Which ones can make a positive 5? Good, and which one should be negative? 2. So we end up with z minus 2 and z plus 7. Am I done? No, what do I do? Good, we take a plus c and we plug it in for z. So we have a plus c minus 2 and a plus c plus 7. Can this be reduced at all? No. Can I factor any further? No, but always ask yourself those questions before finishing the problem. Okay, number 2. What is z going to be on this problem? Good, it is. Okay, I think you guys can try this on your own. Remember, simplify, factor as far as you can. Okay, check with somebody they're sitting by and see if you guys agree with the answer you have chosen. All right, so what did you guys end up getting? Did you guys get 4 factors? Yeah. 4 parentheses? Yeah, I got 3. That's what you should have got. If you got 3 or 2, you didn't go far enough. Okay, here we go. I'm going to do this kind of quickly since most of you have the answer. Let z equal x squared minus 10x plus 21. When I'm talking, you're not. Okay, z squared minus 2z minus 15. What numbers multiply to be 15 and add to be negative 2? Anybody? Okay, so we have x minus 5, or sorry, z minus 5 and z plus 3. Shh. Are we okay? All right, now we plug that back in. Thank you. So, x squared minus 10x plus 21 minus 5, and x squared minus 10x plus 21 plus 3. Then we simplify. X squared minus 10x and 21 minus 5 is what? 16. And x squared minus 10x and 21 and 3 is 24. Okay, so now, factor them. I'm just going to wait if you guys need me to wait. So, what multiplies to be 16 and adds to be negative 10? X minus 8 and x minus 2. What multiplies to be 24 and adds to be negative 10? X minus 6 and x minus 4. Say that one more time. Okay. All right, any questions? Okay. Example 3. Okay, we're going to go let z equal x plus y. We get 25z minus 36 x squared y squared. Anytime you have, sorry, this is z squared. Anytime you have two terms, it's either going to be a difference of squares or it could be cube factoring. Remember cube factoring, it's on the orange poster on the wall if you need to review. But in this case, are these cubes? No, they're squares. Also, you should always check for GCF first. No matter whatever you do, check for GCF. There's no GCF here. So what are my squares? How is this going to factor? 5z in the front of both of them. Good. We have a minus 6xy and a plus 6xy. Can these be factored any further? No. Okay. This is where people mess up. This xy needs to go in for z. These are saying 5 times z. So you need to make sure that you write that as 5 times x plus y minus 6xy. And 5 times x plus y minus 6, or sorry, plus 6xy. And then what would you do at this point? You would distribute. Okay? So we distribute that through and we get 5x plus 5y minus 6xy and 5x plus 5y plus 6xy. And can I factor this any further? No. Because this only has an x, this only has a y, this has x and y, but none of them have something in common. Does that make sense? They'd either all have to have an x or all have to have a y, and that just doesn't happen. Okay, any other questions? Okay, let's move on. So now we're getting to our trig review. And hopefully we all remember SOHCAHTOA. So I could recommend writing this down when you're doing these problems just to remind yourself. How would I find that missing side length? There we go. You guys have said it. Pythagorean theorem. Okay, how do we know which one is our C side? Okay, your hypotenuse or your C side is always across from your 90-degree angle. Your A and B can be mixed up, but your C always has to be the hypotenuse. And again, the hypotenuse is always across from your 90-degree angle. So So in this case, I can find that missing, or that's not c squared, it's just c. I can find my missing side length by using the Pythagorean theorem. So 4 squared plus 8 squared equals c squared. What's 4 squared? Okay, so 16 plus an 8 squared is equals c squared. We add 16 and 64, which is 80. And now what? Good. Take the square root of both sides. You want to do your factor tree on 80. So what numbers multiply to be 80? Okay, 8 and 10. And then 8 breaks down to 4 and 2. And then 4 is, so you got a pair of 2s. 10 breaks down to, good. So we have another pair of 2s and we have a 5 left over. So how do I write that? C equals 4 root 5. So these two groups of 2s, when I brought them in front of my root, what do I do with them? Do I add them or multiply them? Multiply them. Okay? So that means that C is actually 4 root 5. Okay, so now they want us to find sine of A. We know that sine is what? Good, opposite over hypotenuse. So we go over here to our triangle, and you're going to your angle A. So from A, which number is opposite? 8. And my hypotenuse is 4 root 5. Then you want to reduce. So can 8 and 4 reduce? Yes, so anything outside of the root you can reduce. So I'm going to cancel out the 4 and it goes into 8 2 times. So now I really have 2 over root 5, and Alexander is correct. We cannot have a root in the denominator. How do I get rid of the root in the denominator? Good. I multiply by root 5 to both the top and the bottom, and what happens? Good. The 2 root 5s make a 5. And then 2 times root 5 is 2 root 5. And can anything reduce? No. Okay. You try cosine on your own. I seriously want to couple this up, but I'm not going to. You're making me really upset. Okay, so cosine is what? Thank you. Adjacent over hypotenuse. Okay? And adjacent over hypotenuse, what number is adjacent to angle A? 4. Okay? It cannot be hypotenuse. Your diagonal is always hypotenuse. So even though the hypotenuse is adjacent to it, it's not adjacent because it's always hypotenuse. So that means we have 4 over, and then what's my hypotenuse? 4 root 5. And can that reduce? Good. The 4's cancel out. If nothing's left, what's on top? 1. So I have 1 over root 5. Is that good? No. What do I have to do? Good. Multiply by root 5 to the top and bottom. That makes what in the denominator? 5. And on top is root 5. All right, last one. Tangent of A. Did you guys already get that? What is your answer? 2. Tangent means opposite over adjacent. Opposite to A is 8. Adjacent is 4, and that reduces to 2.